Hi everyone. So I believe that you guys remember this piece of code. So let me help you recall. We had written a code where we wanted to launch multiple threads. We wanted to assign each thread with a unique value, and we wanted those values to be printed in a sorted manner. Also, those values were an integer from 1 to n. Okay, so I had a global shared variable called as current, and if it was non-volatile in nature, then our program used to get hung, and that is what has got happened over here. So what was the cure to it? The cure was to make this thing as volatile. So if I make this thing as volatile, and then if I stop this program and rerun it, then you can see that everything works like a charm. Okay, cool. So far, so good. Now, we also got to know that we can get rid of this volatile keyword by making sure that we use synchronized blocks properly. Okay, so I'm removing it for now. And the key problem over here was of memory visibility. And we know that synchronized blocks can help us tackle that problem. The only thing that we have to ensure is that the shared variable should be written to and read from after acquiring the lock on the same object by multiple threads. That's it. Okay. So if I head back to my worker code, I can see that this is the shared variable, this is the shared variable, right? Here it is being read and here it is being written. So whatever I am doing here, that should be done after acquisition of a lock. And whatever I am doing here should also be done after acquisition of the same lock by any other thread. Okay. For that, what I'm going to do is I'm going to introduce a new object that I'll be using for locking purposes. So I'm just going to create a very simple object. I'm going to give it a name lock. Okay. And you might have guessed that I'm just going to pass this lock inside my worker. So of course it will need to intake it. So I'm creating an instance variable called as lock. And now this needs to be injected inside the constructor. And I'll have to perform that thing over here inside the main. So I have already done that. This lock instance is being passed over there. Now, what is it that I need to do? I need to safeguard this and I need to safeguard this. Do you know there is an interesting thing that I have noted? A lot of people, when they get to know about the power of synchronized, they just start using it randomly. I mean, they'll just place synchronized keyword and expect things to work perfectly well. But it's not the right way to deal with things. If you have the tool, you should also know how to use it properly. Otherwise, you might not be able to get the expected results. Okay, so here, what should I do? I should somehow acquire a lock before executing this logic. And of course, I should somehow acquire a lock before executing this logic. Okay, now, what will happen if I put this piece of code inside my synchronized, where I am trying to synchronize on the lock that I have just passed? You haven't forgotten this, right? This is whatever we passed here. Okay, so I'll just cut this line and paste it over here. That's all. Okay, another thing that I'll do is I'll acquire lock on the same object while writing to this current variable. Okay, looks too good. What do you think, guys? If I run this piece of code, what will happen? It is perfect time for you to pause the video and think about it. Let's do that. Okay, so let's just quickly run this piece of code. So the code has run and you can see we are stuck. In fact, we are stuck after just printing 1. Why do you think this has happened? So if you are not able to reason it out, you can again pause the video for a while and think about it. Also, don't think in terms of memory visibility issues, because here, as we are using synchronized block for reading and writing, and we are also making sure we are acquiring lock on the same variable, on the same object. So that should not be the problem. Something else should be the problem. Just think about it. Okay, guys. Just think what would have happened. So let's say you lost multiple threads from your main. Let's say the first thread to get scheduled was T1. The value associated with it was 1. So what happened? It came here, it acquired a lock on this, and it found that this condition is basically false because the value was 1 and current was also 1. Because it was false, it came out of the while loop, exited the synchronized block, which means that it released this lock, and then it printed the value 1, and after that it acquired the lock and modified the current from 1 to become 2. And now when the current became 2, let's say some other thread got scheduled, let's say thread 5, whose value is 5. Value to be printed is 5. Now when it got inside, it found that 5 is something which is greater than main.current, which at that point of time would have been 2. Now it would stay stuck inside this while loop, but even worse than that is the fact that it had acquired this lock. Because it had acquired this lock, it would never ever release it. It would never ever release it. And unless it releases it, any other thread that gets scheduled by CPU, let's say T6 or T2 or T3, will never be able to acquire it. So the worst thing over here is that a thread has acquired a lock and then it is trapped in an infinite loop. Because of that, it is not able to release it, and because of that, any other thread will not be able to acquire it. And as long as any other thread doesn't acquire it, how will it change current? And if that current is not changed, this thread will stay here as it is. So that is the problem over here. And why it is happening? Because we are not using this synchronized in a proper manner. We have learned it that we should use it only for that part which actually is the critical section part. So basically, no need to put this synchronized on top of this entire while loop. Maybe I can have it just for this part of code. So what comes to my mind right away is that I can create a simple private method that returns Boolean, and the name of this method is compare. Okay. Now what this method does is it returns the value of this particular expression. Okay. So it has a Boolean answer which is initially false, and then all that it does is inside a synchronized block guarded by that lock, it changes the value of this answer based upon that expression. So answer is basically equals to this particular expression. Now guys, you can quite easily notice this thing that we are reading this shared variable, but we are doing that inside the lock. Okay. And after releasing this lock, I can go ahead and return this answer. Looks good, isn't it? Now I can just have this piece of logic placed over here, and then I can completely get rid of this synchronized thing that I had placed here. So it's the same thing, but it's being done in right manner now. See, previously also I wanted to do something after acquiring lock. Right now also I am doing the same thing, but currently I am doing it for a much smaller portion of the code. Earlier I was doing it for the entire while loop, because of which there was a problem. Okay, cool. So this is good. There is no issues with this. This will not create a problem. Okay. So now if I rerun this piece of code, let's see what happens. So now you can see it perfectly runs well. You should in fact try running it again and again, and every time you will see it runs perfectly well only. The important thing, however, to keep in mind is, like the point that I wanted to tell you was that I can get rid of that volatile and get my entire job done by synchronized blocks only. Synchronized is just a construct. The idea is that acquire lock on the same object while writing to a variable, and acquire lock to the same object while reading that variable. Multiple threads should take care of that thing. Okay, so this was a fairly simple example where we saw how to apply this thing. Now we might encounter a lot of problems where you will have to do a lot of thread synchronization, and you know what are the key enemies that you have. The first enemy is race condition, and then you have memory visibility. You also have instruction rearrangement, but the good thing is that you can take care of all these things by doing locking. The only thing that remains is some synchronization algorithm that you have to think on your own. Like here, I actually thought of a synchronization algorithm where I felt the need to create a shared variable and how that shared variable is modified by the multiple threads. Yeah. So you will see a lot of questions like these, and they will hone your skill of dealing with concurrent programs.